Okay, everyone, let's take a look at Module 26104-23, Electrical Theory in the NCCER 11th edition. This will be section 1.00, Resistive Circuits. The total resistance in a series circuit equals the sum of all resistances. Resistance total for this circuit would be R1 plus R2 plus R3. So this circuit has a 50 ohm, 75 ohm, and 100 ohm resistor in series. Those added together would be a resistance total of 225 ohms. Identifying resistance in parallel. Most practical circuits are wired in parallel. Three methods for calculating resistance in parallel circuits are the reciprocal method, the product over sum method, and the method for equal resistances only. Using the reciprocal method, RT would equal 1 divided by R1 plus 1 divided by R2 plus 1 divided by Rn, where Rn would just mean keep adding all the resistors that you have. Finding total resistance using the reciprocal formula. Find the resistance for a 2, 4, and 8 ohm resistor in parallel. That 2, 4, and 8 ohm resistor in parallel would come down to be 1 divided by 0.875 ohms, meaning the resistance total for that parallel circuit would be 1.14 ohms. Using the product over sum method, when there are only two resistors in a parallel circuit, RT equals R1 times R2 divided by R1 plus R2. Find the total resistance for a 5 and 10 ohm resistor in parallel using that method. That would be 50 divided by 15. Resistance total would be 3.33 ohms. Using the formula for equal resistances in parallel, if resistors are equal, resistance total is the resistance of one resistor divided by the total number of resistors. Calculate the equivalent values. Two 200 ohm resistors and one 100 ohm resistor. Two 100 ohm resistors would equal 50 ohms, and two 50 ohm resistors would equal 125 ohm resistor. Working with series parallel. To find the current, voltage, and resistance in a series parallel circuit, apply the correct rules for each part of the circuit. Recognizing series and parallel combinations. Trace the paths to identify branches and loads. For more complex circuits, you may have to redraw them so they are easier to recognize. Reducing series parallel circuits. To find total resistance, reduce the circuit to its simplest form. Apply the rules for series and parallel circuits to combine the values of all resistors into a single equivalent value. And here's a trade term you should become familiar with for this session, and some review questions for this session. You can use Ohm's law to find the value of each branch in a parallel circuit. True or false? That would be true. Which of the following is true regarding a parallel circuit? It has more than one path for current to flow. The resistance is the same through all circuit components. The total resistance is equal to the sum of the individual resistances. Current flow through each resistor is always less than the total resistance. It's going to be A. It has more than one path for current to flow. Which of the following is true regarding a series parallel circuit? There is only one path for current flow. The resistance is the same through all circuit components. Once reduced to an equivalent series circuit, the total resistance is found by adding the series loads. The current flow through each resistor is always less than half the value of the total resistance. That would be C. Once reduced to an equivalent series circuit, the total resistance is found by adding the series loads. Okay, everyone, that was it for that section. The next section will be 2.00, Ohms and Kirchhoff's laws, and I'll see you over there.